let's move to the one of the most important type of spillway, that is Ogee Spillway. See, as compared to the other type of a spillway, this type of a spillway is completely and basically it is said that it is generally used for the gravity dam because it is adopted along the body of the dam, along the length of the gravity dam. So, at the maximum reservoir level, it will be constructed, keeping the crest level is equal and is parallel to the maximum reservoir level. And once the water will get increased and water will get raised up, then this flow of water, this surplus water, will carried out through this Ogee shape, through this Ogee spillway. See, generally, this profile of the spillway is of a S shape. Here you can see this. This S shape, this profile has the shape of this spillway is like the S shape. Hence, it is called as a S shape spillway as well as it is also called as a Ogee spillway. So basically, in this type of a spillway, the overflowing water is glided smoothly over the crest and profile of the spillway so that the overflow water does not break contact with the spillway structure. That's the reason why we are adopting the Ogee section, Ogee profile in our gravity dam. We know that the energy when it is or the water when it is increased, this water has a maximum velocity. Because of that maximum velocity, it possesses the maximum kinetic energy. So this kinetic energy, once it smoothly glides and once it glides and once it adhere to this section of the spillway, definitely some at the some section or at the toe section of the spillway, at the downstream section of the spillway, this energy will get dissipated because of the formation of a hydraulic jump or any other energy dissipating work if we are providing. Then because of such a provision, this energy will get dissipated and will becomes completely zero, and this water is then freely, safely discharged into the natural water flow, that is in a river flow. So this is the reason why Ogee profile, Ogee shape has been adopted. In previous type of a spillway, you have seen that the some of the spillway is being constructed, is being submerged into the water level only. Some of the spillway is constructed in the body of the dam, not along, but in the body of the dam by asserting or by forming a siphonic action. This flow will be taken place, but in that particular type also, the siphonic action will be totally depend upon the head that you are going to provide. If some of the levels, some of the difficulties may arise during the flow of the water in the siphon, then the water will get clogged at one section or in that particular siphon pipe, and this flow will not occur properly. So this is the main disadvantages of this siphon spillway. Even you can see the side channel shaft, then you have a straight drop also. So in straight drop spillway also, you have seen that this water will come over from the upstream and it will continuously exert the pressure on the bed section or on the downstream part of the spillway. So the suction and the cavitation that will be created in between the jet and the surface of the spillway, in that region the negative pressure will be created, negative pressure will be formed. So because of this, the cavitation will be formed and your bed get completely eroded. completely distracted, completely disturbed. So to avoid this, here the Ogee is the bestest option, bestest type of a spillway. See, if this is not assured, what not assured, the overflow water that completely continuously make a contact with the spillway surface. If it is not assured, the vacuum may be formed in the point of a separation and the cavitation may occur. So, in addition to the cavitation, the vibration from alternate making and breaking of a contact between the water surface and the surface of the spillway results in a whole structure may get damaged. So hence the upper profile of a Ogee is made to conform with the lower nap of a freely falling jet of a water over a sharp crested weir. See, to avoid this, generally we are giving, or we are constructing a sharp crested weir on the upstream section so that this Ogee upstream and the upstream profile of the Ogee that will be rely on this sharp crested weir that will be raised at certain height, and because of this the water that will be coming, that will be passing above this upstream crest profile, it will smoothly glides and it will continuously there sticks to the complete profile of the Ogee spillway. This is the reason. That's why we are adopted this sharp crested weir on the upstream section. See, when the flow rate corresponds to the maximum design capacity of the spillway, we need to construct the sharp crested weir on the upstream side. Here, the essential difference between the straight drop spillway and the Ogee spillway should be clearly noted. Because of this reason only, we should avoid the straight drop spillway. In the former type, the jet falls clearly away from the face of the spillway, and the gap between the jet and face is kept ventilated. You have seen in the straight drop spillway. In that particular spillway, the jet of the water continuously fallen on the bed of the channel, bed of the downstream part. But the part between the jet of the water and the spillway, this is remain ventilated like this. Once it is come over here, it will not attach to this portion. This portion remain ventilated and the cavitation will be formed in this region. See, in the Ogee or Ogee overflow spillway, the following water is made to bleed over the curved profile of the spillway. This is your profile. This is your sharp crested weir. Why we are providing this sharp crested weir? Because on this sharp crested weir, here your upstream crest profile will rely. So because of this increased portion, once here your normal or maximum reservoir level is there, once it will get increased, so smoothly it will attach to this section, and again with this curve section, this water will glides over without disconnecting with this surface, and it will come here, and after coming here certain bucket will be provided to raise to form a hydraulic jump so that the energy which is coming and which is falling over this section will get completely, not a completely dissipated, but certainly dissipated at around a 75 percentage, and after this water will carried out further in the forward direction. So in this manner the Ogee shape and Ogee profile will be adopted. A smooth gradual reverse curvature on the downstream face, that is called as a bucket, that will be provided. See, this reverse curve turns the flow. This reverse curve, this reverse curve turns the flow on the apron of a stealing basin or into the spillway discharge channel. So this water that will be coming over here, that turns the flow to move in the reverse direction, and because of this action leads to form a hydraulic jump, and again it will be raised up and it will be flow in towards the stealing basin area. And again after coming here, if we are providing the another energy dissipators towards the downstream part of the spillway. Then because of this stealing basin area, again the remaining 20% of energy will be dissipated, and after coming here, your water carries a 0% kinetic energy. It will completely dissipate your energy into 0%, and it will be safely discharged into the river or into the natural water resources. See, before proceeding for the design of a Ogee spillway, here we need to study some important technical part, that is when it is said to be a high overflow and when it is said to be a low overflow. Okay, so see, for judging this, for deciding this here, the Ogee spillway is said to be a high, uh, depending upon the ratio of a height of a spillway crest. See, this is your, if this is your spillway, generally up to this crest point you have a water surface area, and this will be denoted by P, the water which is available on the upstream side. It is depending upon the ratio of a height, this height crest, which is measured from the river bed to the design head. Design head is nothing but the distance and the vertical distance from this water surface level, up to the crest of the spillway, or the highest point of the spillway. This distance is known as the H, that is a head, or it is said to be a design head. So in this region only, once the water will get increased, so this surplus water will carried out towards this, hence it is called as a design head. So when this ratio P by HD, this ratio is greater than or equal to 1.33, it is greater than or equal to 1.33, then it is said to be a high overflow. And when it is less than or equal, not equal to, but it is less than 1.33, then it is said to be a low overflow spillway. So based on this condition, we are dividing this overflow section into a high or low section. See, in the case of a high overflow spillway, the velocity of approach, generally, yes, we are looking forward this, what is exactly a velocity of approach head, what is exactly total energy head, that we are studying in the next slide. Generally, the velocity of the approach head, which is which is in the order of a 0.04 multiplied by h or less, may be considered is negligible. Let's see what in what manners these head are divided and head are decided. See, the distance measured vertically from the water surface to the crest axis. Here in this diagram you will get a complete idea that this head, this is the upstream reservoir level. From this, the vertical distance that will be measured or that will be calculated is known as the head. Is known as the head. The distance measured vertically from the water surface to the crest axis is known as the head. Now, what is the design head? When the design head is that value of the head for which Ogee profile is designed. You can see here this distance is nothing but a vertical distance. Again, it is measured from the water surface, but this distance, this is the value. By adopting this value, we are designing this Ogee profile. This HD is the main, has the main importance and has the main role for the designing of a Ogee spillway. So we have seen the two head, that is one is the head, second one is the design head. So yes, you remember, if you remember, for deciding the high overflow and low overflow, generally this is denoting by a P. So this P by H suffix D, that is design head, when it is greater than or equal to 1.33, it is said to be a high overflow, and it is less than 1.33, then it is said to be a low. So remember this ratio. Based on this ratio, we have deciding that we are going to deciding that whether it is high or low. Now let's see the third head, that is head due to the velocity of approach, that is denoted by HA. See, it is the velocity head. Generally, when we have decided, when we have saying that the surplus amount of the water, so this surplus amount of the water carried out a tremendous amount of a kinetic energy. So kinetic energy is nothing but the velocity head. So for finding out this, we generally has the equation like velocity, that is Va square upon 2g. So by substituting the value here, Va is nothing but the velocity of approach. So by substituting this value, we can find out the HA, that is head due to the velocity of approach. And when it is to be considered in the high overflow, when certain condition occurs, so it should be less than 0.04 into H. If that value occurs, then we are neglecting that value, neglecting that velocity of approach, head due to the velocity of approach. But this value, if becomes greater than 0.04 H, if it is greater than this value, then definitely we have to consider this velocity due to this head due to the velocity of approach. The last one is a total energy head. This total energy, we know that total energy is nothing but the potential energy plus velocity energy plus datum energy, right? Here, potential energy, that means the water is remain into the stable condition, the actual head we can say. And the velocity, we are neglecting that term, we are considering this will be at a water free surface area, so it will be become zero. Here velocity head or velocity due to the head due to the velocity of approach is nothing but a HE. So HE becomes H or design head plus head due to the velocity of a approach. So these are the four main head categories, and here they have shown you this head in terms of a diagram. So this is the sharp crest layer. You can see the head that will be rely on this. It is simply a head. See the value which is help for designing the Ogee profile, that is called as a design head. You can see here. Here, the Ogee Spillway with the greater flow, you can see when the when the head is greater than the design head. So what happened exactly? If such a condition occur, this separation, this contact between this water and the surface will get separated. Here you can see here, and because of this separation, the turbulence will be created and this section will get eroded. So for avoiding this, for rejecting this, here the section elements of that sharp crested profile, in that manner we are going to adopt. So here you can see the vertical face is adopted, sharp crested we are vertically provided. Among this is upstream crest profile. Upstream crest profile will be designed based on the one of the equation that we are going to study in the next slide. This will be considered as the origin. This will be the apex point of the spillway crest. At this point only, this is the peak point, highest point. So by considering this as the origin, we are again generating, or we are again designing the downstream crest profile. So for designing this crest profile, here we are using one of the equation here, and this is the how we are going to design Ogee Spillway. So let's see one by one. I hope you understand all the four head factors, head parameters, as well as the how we are going to decide the high overflow and low overflow spillway. So let's start with the Ogee profile. See, generally the Ogee profile is to be acceptable, which should provide maximum possibly hydraulic efficiency, structural ability, stability, and economy and it also avoid the formation of a objectionable subatmospheric pressure at the surface. So if such a profile is there, so we can say that yes, this is a Ogee profile. So you have seen in the diagram, previous diagram, that sharp crested weir which have the form of a underside nap of a sharp crested. So the ideal spillway should have the form of a underside nap of a sharp crested weir. When the flow rate comes downstream to the maximum design capacity of the spillway, so however the head during an unanticipated flood may rise higher than the design head, and because of this the lower native of the falling jet may leave the Ogee profile and the separation will be created and the negative pressure will be developed. So on the contrary, when the head on the spillway is less than the design head, when it is happen, when this head is generally less than, we should keep this condition, we should adopt this condition, we should keep the edge is always lesser than this hd design head. So that this is following falling shade, it should adhere to this profile of the Ogee, which causing the positive hydrostatic pressure and reduce the discharging capacity. And if this condition occur, what happen, the separation and the cavitation will be occur and negative pressure will be developed and the turbulence of the created on the downstream section, and it will get affected on the downstream part and whole body of the spillway. So generally, let's start with the design part of our Ogee profile here. When here we are considering that our crest profile, our upstream profile, it is a vertical, and second condition is that our upstream part and upstream profile is the inclined one. So we are dealing with the first condition, this condition when this vertical face is the vertical one. So for this basically remember one thing, we require here our component part for the designing of the Ogee spillway is we need to decide whether it is a vertical one or not. Then we need to design this from this point up to the peak point of the spillway crest is considered as a upstream crest profile of the Ogee spillway. By keeping this as a origin, this peak point as a origin, again we are designing the downstream profile here, the downstream profile of the Ogee spillway. So 1, 2, 3, and again this fourth one is the bucket design of a reverse curve that is called as a bucket. So we need to check and we need to design these all the parameters, right? So let's start. See, when your crest is a vertical one, so for the design of a downstream part, for this downstream profile, generally we have an equation that this the basic equation, it is in the form of x is to n into k into hd raised to n minus 1. Wait, I will show you. See, x raised to n is equal to k into hd raised to n minus 1 into y. So this is the basic equation, but when your upstream profile is the vertical one, you should adopt the value as x raised to 1.85 is equal to twice into 2 is the k factor into hd design head raised to n minus 1, 1.85 minus 1, that is 0.85 into y. This equation you should adopt. So after adopting this equation, you will get certain x and y values. So here you need to plot these values one by one here, and you will get a certain point. Up to this point, you have to draw the curve section, and beyond this portion will be in a straight line. Now, after getting this straight line on the downstream part, you need to again reverse it. Again, you have to increase that portion in a reverse part. That is a bucket portion that you have to provide. So remember that if when you have a upstream profile is a vertical one, you have to adopt this equation. Now let's see the design criteria for the upstream crest profile. Now you see that for the downstream crest profile, you are using this equation, right? Now let's see how you are going to find out how you are going to design this upstream part, this small curve part. Let's see. See, the upstream profile should be tangential to the vertical face. See, this this part, this part, it should be tangential to the vertical face, this end of the vertical face. It should have a zero slope at the crest axis to ensure that there is a no discontinuity along the surface of the flow. It should be having a zero slope. The recommended curve given below incorporates the coordinate computes computed in the region close to the sharp-crested weir, where accurate experimental data measurements are difficult, and fits the experimental data over the remaining portion. So here, according to the latest analytical studies of United States Army Corps, the upstream profile of Ogee Spillway can be designed by using this equation. This is the major and bigger equation that will be adopted for designing the upstream part of the your Ogee Spillway. Here you have equation, you have the value of xd. We have find out, or we have that value in the numerical. Just you need to consider this x value, you need to change the x value. So with this x value you will get the y values. So likewise, after getting the x value, x1, x2, x3, so based on this value you will get a y1, y2, y3. So likewise, for this x1, the y1 value that you have adopted, that you have get. So here you need to plot this value, this x value, and this y value. So after putting this value, definitely you will get a certain curve, price curve, and after getting that curve here, definitely you will get one point. Now by considering this point here, you are starting to design the downstream profile of a Ogee stream. Yes, I'm showing you in this in the numerical part. Definitely you will clear your doubt, you will get clear your doubt. See, it should be noted that the upstream curve at the crest should neither be made too sharp or not too hard. A border curve at the crest supports the lower nap, produces the positive hydrostatic pressure, and thus reduce the discharging capacity. If the curve is a very sharp one, the nap will leave the Ogee profile, causing the negative pressure, and consequent cavitation will be provided forming, and increase the coefficient of the discharge. So here, the dimensionless coordinate of upstream profile value is given. See, when the value is taken as x as a 0, or x is to h by d value is taken as a 0, you will get a y is to 0. So like this, they have done the various researches. United States Corps Institute had done these researches for the developing the upstream profile. You can see from 0 up to 0.27 or 0.126, up to this value they have find out. So after doing this research, they have included that this value is suitable. By adopting this value, this curve that will be provided for this upstream curve, it will be not nor a neither a too sharp nor a very hard. So by adopting this value, your flow will get smoothly glades over, and it will be completely adheres to the downstream section. So according to them, this value is a perfect, and this value is a we can say the efficient one. So by adopting this value, we are getting the upstream crest profile as a tangential to the sharp crested weir, as well as it should not have any slope for the crest profile. So according to them, this value is very suitable value. Now we have seen that when the upstream phase is the vertical one. Now let's see when the upstream part is the inclined one, then what happened? See, generally the that equation that we have using x raised to n is equal to k into x hd raised to n minus 1 into y. This equation depends upon the head over the crest, inclination of the upstream face of the spillway, and the height of the spillway crest above the stream bed or the river bed. So, based on the extensive experiments conducted by the US Army Corps engineers, they have developed the several standard crest of overflow spillways at its waterway experiments station at Wickerburgs. So this gives us the for both the for vertical as well as for the incline. So here are the values. Here are, see, you can see the equation. According to them, in the IS code 6934, they have also adopted and recommended this shape, and basic equation we are using is this, right? Now in this, the x and y are the coordinates of the profile of the crest of the spillway, and the hd is the design head. K and n are the constants value. Here you can see, and it depends upon the this constant values totally depends upon the slope of the upstream face of the spillway. So for the vertical face, yes, we know that K will be adopted as 2 and N is adopted as a 1.850. But once the slope has been given like this, your vertical, your upstream face has the slope as the 3 vertical to the 1 horizontal, then you have to adopt K value as this 1.936, and your n value becomes 1.836. So equation becomes x raised to 1.836 is equal to 1.936 into hd raised to 1.836 minus 0.836 into y. So when the slope is 3 vertical to the 1 horizontal is there, then you should adopt this equation. When the 3 vertical to the 2 horizontal is there, then the k value becomes 1.939 and your n value becomes 1.810. Again 3 vertical to the 3 horizontal, definitely your value again changes. So depending upon the slope value, depending upon the horizontal and vertical value, you have to use this equation. You have to change this equation, this n value and k value according to the slope, and you have to put this value in this equation. But remember, when the upstream face is the vertical one, your equation remains same. Your equation becomes or remains same. K value is 2 and your uh, n value is 1.85. Okay, so this is the when you have the upstream face as a slope 1. Here you can see this equation you have to adopt. See, further design of a downstream profile, that means when we need to give a certain bucket section. See, the equation that we have derived, it is applicable only for the positive values of x and y, and it gives the crest shape downstream from the vertex for the origin of the coordinates. The curve profile of the crest is continued till it meets the tangentially the straight sloping surface of a downstream face of a overflow dam. Means this portion is remain curve one until and unless it will get a point of tangency. So from this point we have to draw a straight line. The location of the point of tangency, this location will be depends upon the slope of a 0.7. It varies from 0.7 to the 0.8 is to 1. This is for the horizontal and this is for the 1 is for the vertical. So based on this stability requirement, we need to fix the location of a point of a tangency. See, at the end of a straight sloping face of the spillway, here at the end of here, at the end of this point, generally the curved circular surface, that is a bucket, will be provided to create a smooth transition of a flow from the spillway surfaces. So for this, here we have an equation. We need to design, we need to find out the radius of that bucket. The general equation we have, that is r can be found out by using 10 raised to alpha, and this alpha is again found out by using this equation. But it totally depends upon the velocity, v factor, design head factor. Then we have to put this value in this equation, and then we are finding out the r. But generally they have said that the r should be adopted as p by 4. P is nothing but the level of the water which is present on the upstream side. So it should be a one fourth of that height of a water. It is satisfactorily. So we can adopt this value, and we can design, or we can set up this bucket on the downstream part of the our Ogee Spillway. So yes, we have seen in the numerical how we are going to fix that bucket value. Just remember this value, R is equal to P by 4. Now let's see how we are using, or how we are finding out a discharge for the Ogee Spillway. When we have adopted the Ogee shaped spillway, here is the equation. Q is equal to CD, coefficient of discharge, into LE, effective length, into HE is the total energy head, or we can adopt a design head also, raised to 3 by 2. CHE is nothing but a design head plus head due to the velocity of approach. So generally, depending upon that value, when we said that 0.04 h is the value is less than, then we are neglecting the HA value. But it exceeds than this value, then we should adopt the, or when we should consider the velocity of approach also. But here we are neglecting, so HE becomes HD. So we can adopt this value as the design head also, raised to 3 by 2. So here CD, that is coefficient of discharge, the value varies from 1.6 to 2.28, you can see here. And LE, that is effective length of the crest, can be found out by using this equation. L, that is the net length of the crest, minus twice N is the number of a peers, number of peers, multiply by the kp. Kp is nothing but the coefficient of a peer condition. What shape has been given to the peer. So based on this peer shape, here we have the various value of a coefficient value with us. Then Ka is the abutment coefficient. So based on the abutment shape also, we have the coefficient of a abutment value with us. And here is the HE again we can consider as a design head. So by adopting all these values, generally for the better discharge value, for the maximum for reducing the discharging capacity, we are adopting the Ogee, and Ogee has the S shape, has the curve shape. So generally for this we are adopting the kp value as a rounded one instead of a square and pointed. So remember one thing, while designing this we should take the value as a kp as a 0.01, and here abutment value should be a rounded and having a 90-degree angle with the face wall, head wall. So here we can adopt this value as a 0.10. So here the number of peers has been given, the length of the crest will be given, and the HD value is also given. So by substituting all this value in this equation, we can easily find out the discharge which is passing over the spillway section, Ogee spillway section. Now last part that is related to the Ogee profile is Ogee, that is like a gravity dam. We have seen the elementary profile as well as the practical profile. Practical profile is that by adopting or by designing all the section, or considering all the points here, generally we need to change, or we need to give certain modification to the profile. See, you can see in this diagram, when the Ogee profile is plotted over a triangular profile of a non-overflow section of a gravity dam. You can see here, this is your dam profile. This is your dam profile, and when we plotted this in the triangular section, triangular section. So what happened? It is found that the downstream curve profile of a spillway goes beyond the straight downstream face of the dam, thus requiring the thickening of a downstream face to accommodate the Ogee profile. Here you can see if a triangular section that will be adopted, this triangular section when we adopted the dotted line. So what happened on this downstream part, you can see this thickening. We need to do the thickening on this downstream part to gain the to complete the Ogee profile. So for this, the extra concrete can be required for the thickening purpose. So we should avoid this by getting and by designing the Ogee profile and by getting the practical profile of a spillway. So generally, the this thickening can be saved by shifting the curve. This thickening can be saved by shifting this curve towards the upstream direction. Here you can see towards this upstream direction, so that till the Ogee curve becomes tangential to the downstream face of the dam. Here you can see this thickening will be shifted here, and this will be tangential to that portion, so that the water that will be raised, that will be come here without any hesitation, that will be contacted remain contacted with this downstream portion. See, such a shifting of the Ogee profile towards the upstream side will give rise to the projection portion that is called as a corbel. You can see here this corbel has been given here. So because of this corbel, this part will give the support to this vertical section of the dam and vertical section of the spillway. So no need to give any concreting for such a vertical section. So here we are providing, now we are saving the quantity of a concrete that will be using and that will be required for this section. Here you can see the concrete saved for this particular area. Corbel has been given. This thickening part will be stretching over the upstream side. So because of this, here we will save the concrete and we can design this profile in the economic manner. So this is the reason why we are adopting this, uh, Ogee profile. So the very important profile, important type of a spillway. In next video, we are going to study a numerical based on this Ogee spillway. Thanks for watching this video.